Today we're going to explore how digitalizing your cable design and manufacturing processes can significantly improve productivity across the whole factory. I'm delighted to be joined by two experts from within the wire and cable industry. Hamada Khalifa, the commercial technical lead at Cimteq by UL Solutions, and special guest Amanda Shehab, wire and cable industry consultant. So again, we thank you for being with us here today, and I'll now hand you over to Amanda Shehab. Thank you, Amanda.
Thank you very much, Ken. So first of all, a big welcome to everybody and thank you for attending this webinar. So we're going to start off by having a look and trying to unravel the black box of a cable manufacturing factory. So looking at the very, very big picture, we have a wire and cable factory, and into that factory we have raw materials, so copper, aluminium, compounds, all the mix of materials that feed into that factory to give us the final products. And then in the middle something happens. So we have lots of different pieces of equipment and machinery that do all sorts of different processes and all sorts of very complex interactions from one process to the next. And of course, we also have people that are trying to manage this complex process in order that in the end, hopefully, we get cables coming out of the door that are good quality, the right length, the right spec, and delivered on time. So the big issue really is what's happening in here. And what's happening in here is actually, when you think about manufacturing processes, is actually really complicated to bring everything together to get these outputs as and when we need them. And so maybe we need some help to help us do this. And one of the ways that we can improve is by using a manufacturing execution system. Now, MES system for any type of manufacturing, its job really is to track and document the transformation of these raw materials into the finished goods. And as it's tracking these materials, it is helping us to better manage the processes that are going on internally so that we can improve and reduce costs. So let's open up this black box, this factory. So as I said before, an MES system, it's not going to solve all the problems, but rather it's a tool to open up your factory and allows us to look inside in minute detail to see what's really happening across the board. And that means that we can look what's happening right now. So right now, this minute, in the last second, what's actually happening. We can look back or look what's happening for the rest of today, yesterday, last month, last year. And very importantly, it helps us to look what's going to happen tomorrow. And that's not really about scheduling such. It's more like looking at our past performance and what our trends are of what are happening across different areas of the factory. It can help us predict, if we continue as we are, what's going to happen tomorrow, and therefore it helps us to facilitate changes that will help us improve for tomorrow. So we've now opened the box and we've got tools that can help us. What are we actually looking for? And really, we're looking for any form of waste. So we want to eliminate waste. And in a wire and cable factory, the most costly form of waste are found, of course, in materials, because these are the biggest cost in the cable, but also in the equipment, because capital equipment and machinery is expensive. So we want to make sure that we're utilizing that to its maximum capabilities. So looking a little bit more in detail, if we look on the material side, there's sort of 5 points. There's probably more, but there's 5 points I've picked out that we're going to look at in more detail. So the possible waste points for material are unused raw material coming into the factory. So we've used certain amount of the batch, but there's leftover amounts in various places that really it's waste. The big one, of course, is if we have any scrap product waste. So we've made product, we've processed it, we've added value to it, and it's not fit for purpose, it's scrap. The next one is process startup and shutdown. So a lot of manufacturing processes you can't avoid these wastes, but it's all about minimizing them. Material overusage. This one is a big waste if we don't keep control of it. It's basically putting more material onto the product than is required. So it's an overspec'd product that we're just giving material away. And the final one is here to look at is length waste. So length, we're delivering length to a customer based on how much length they've purchased. We don't want to be measuring inaccurately or, adding a little bit here and there just to play it safe, so that at the end of the day, the customer's being given cable for free. Moving on to the equipment side. So again, just 5 points picked out here. So the first one, using equipment for rework. So this follows on from the scrap issue. So if we've made some scrap or bad quality product and it has to be reworked, that product now has to go through machinery that should be used for making cable the first time around, not for using rework. So it's wasting that resource when it should be producing the proper output. A big one, the running below the design speed for a machine. So every machine, we should know what its design speed is for every product, for every material, and we should be making sure that we're running as close to that as possible. Downtimes, there's downtimes due to setup or downtimes due to unplanned maintenance. Both of these, they're really unavoidable, but again, we need to minimize them. And another one that's really shouldn't happen is downtime due to lack of materials or people. So if a machine is stood waiting, not running because materials aren't there or people aren't there, then that is a huge waste, and we need to, with better planning, we can avoid that at all costs. So we're going to now look at a little bit more detail in each of these 5 points for each topic. So first of all, looking at the unused raw materials side of things. So it's quite easy to get small leftover batches of materials that they can add up if they're distributed, over time. They'll add up to a very, very costly waste. So the way to solve this is having proper real-time visibility of where these materials are and accurate information on the quantities of these materials. So that having an MES system gives us this actual, very accurate, on-time view of all our materials across the factory. So that means we can better plan to utilize these materials. So if we know the quantity of a material and we're going to have rather a large amount left over after a particular run, maybe we can use that material somewhere else. Or if we have various batches of materials dotted around, we know the locations, we know the quantities, maybe we can group these together to then form something that can be used in a run and utilized more of them. Scrap, of course, it can be produced for many reasons, but the thing about scrap, something can always happen that's going to start basically us producing a scrap product. But the thing is, what we need is a good quality management system, so that as soon as a product goes out of tolerance, as soon as there's a chance that we may or may be producing scrap, then an alert needs to be made and flagged up so that something can be done about it. And essentially, we need to stop producing that product immediately, because we don't want to, first of all, we don't want to finish that run and then, even worse, let it go to add further value at further processes. We need to stop it at the source, so prevent it from continuing and take action. And here, this is where an MES system comes in and is excellent, because the quality management within the system will make sure that this happens. Process startup and shutdown. Again, it can't be avoided in many processes, but what we should have, and this is crucial, so this would come really as part of the spec of the cable. So when we spec a cable and design it, we don't just design the product, but we're also designing the process. And in that process, we should know how much bleed we expect from the extruder, how much waste, how much product are we going to lose going through the line before we actually start making good cable. So all these parameters should be designed as part of the spec in the design system, so that when we actually come to make the cable, we can compare and say, okay, yeah, we were supposed to lose, 10 meters on startup, and we continually using 15. Why? And we can look into it. So that the key here is to compare what we expect versus what happens, and do something about it if they differ. Material overuses. So yeah, so this is very easy because we don't want to make scrap. So it's generally we play it on the safe side. So that generally means if we've got a nominal target figure for the spec, a diameter, we're going to perhaps always go play it safe, go a little bit over that nominal. And this can happen in all processes. Basically, it's easy to play it safe, but we're giving material away, so we really do have to keep. If we can stay as close to nominal as possible, then we're going to save quite a lot of money. And this is again an MES system, as well as looking for bad product through the quality system. If we have an over-specified product, so we can see that during the manufacture we are seeing that is actually over spec, then again, flag can be raised, production can be stopped, and we can do something about it to stop us giving material away. And at this point as well, if this happens early on in the process, so we're making a bigger cable than we need to be, every process further on is going to also, it's just going to get worse, because the cable is, every process now on, you're starting off with a bigger cable and you're going to have to use more material to make the next process in spec. So this has to be stopped early on and not let it progress. So the final one on the material topic is length. So there's a British saying, how long is a piece of string? I'm not sure whether it's an international saying, but you say it a lot in Britain, and it kind of fits for us making cable, because that's what we're doing really. We're making pieces of string, but are these pieces of string, are they too short, are they too long, or are they just right? And if we don't get them just right, we're losing a lot of money, because if they're too short, then maybe it's not going to meet the final length that the customer ordered. So maybe we have to negotiate a new price, or maybe the customer won't take it and it's potentially scrapped, or it goes into stock for who knows how long. And on the other side, of course, excess lengths. If we're making excess length, again, that's just giving material away. So having an MES system allows us to monitor this, and again, a short length can be stopped. Stop adding value, don't let it progress until we're sure that we can actually still sell it. And an excess length again should be stopped. Maybe it can be reassigned to a different order, so that we're not actually, and we can get paid for it rather than giving it away. Okay, so some maths. So I apologize for the maths, but just picking on the topic of material overusage. So say we're on an extrusion process and we have a target diameter of 13.4, and we start making the cable and we're coming in on an average of about 13.5. Now, if you have some tolerances around that target, if you've got 2% tolerances, 13.5 is well within those tolerances. That potentially is good. There's nothing wrong with it. I'm making good cable there, but we're still actually giving material away. In fact, maybe not even to the target. We could go to the minimum. So if we went to the minimum, we would save even more. But if you follow the maths through, and the kind of my numbers, so take them with a bit of a pinch of salt. But basically, by my calculations, for every 1,000 meters we make using a compound of HDPE, we're giving away around 2 kilograms. So 2 kilograms is wasted every 1,000 meters by just putting 0.1 of a millimeter extra on. So that works out my figures, granted, but you could put your own figures in this later to see what you come out with for your own products and costs. But that means we're losing £6 every 1,000 meters. Now that's just 1 kilometer, yeah, and that's just one process. So if you think how that would multiply up for the hundreds of thousands of meters that will go through the plant every week, every year, then that £6 can multiply into a huge amount. And if this is just actually looking at your processes and trying to get closer to your target or your minimum. Anything that actually goes over that, then the losses would be extremely big. Okay, looking at equipment wastes now. So rework, again, we said, so rework generally is caused by making some bad quality product. So again, it's about the good quality management product. So it's not the fact to solve this. It's not to solve rework, basically we have to stop making bad quality products. So again, it goes back to the quality management system. So less scrap means less rework, and machines make their intended products instead of having to rework existing products. So running speeds. Now, I think this is a big one. And it's, again, it goes back to the design and the spec of the process that goes with the manufacture of the cable. So we should know for every single machine, for every single product, for every single material, what the spec speed is. And when we run, we should run at that spec speed. And if we're not, it should, by the MES system, be flagged that we're not, so that something can be done about it. And that's in real time, so you can see right now what's happening. My machine's running slow, but also historically, so you can do analysis to say, okay, on a Tuesday afternoon when it's raining, my machine's always run slower. And then I don't know why the reason is, but you can look into what the reason is and do something about it. So it's both the running speeds, the system needs to flag them when it's happening now, but also you need to look at historically what causes speeds at lower than target. So yeah, setup. So again, this is about, we can't avoid setup. That's the nature of the game, but we need to have a very precise view of what those times should be, and be quite strict on recording them and comparing the actual times to the ones that we've spec'd. And when they differ, then we need to do something about it. And again, so this is really, it's a case of designing the process and knowing what the setup times are, and then comparing the actuals. Breakdown, yes. So equipment will always break down, and this can be a big problem, especially if it's a bottleneck machine, something that is key to the factory. So the best way to avoid breakdowns is have planned maintenance schedules, so that the common breakdowns will be avoided because the machine is kept, in tip-top working order. So one of the things an MES system can do to help with this is we can actually automatically monitor running hours of equipment, cycle times, so that we will know based on the spec of the equipment when maintenance is due, and it can then be planned based on that, and hopefully will avoid unexpected breakdowns because we've maintained the machine in time. And the final one is sacrilege, really. It's missing material. So a machine cannot produce if the correct materials, WIP or raw materials, are not in the right place and at the right quantities at the right time. So it's to achieve this, we need to make sure that we have knowledge, again, and visibility of all materials, and we can see what's required in advance to make sure it is there in time. So a machine sat waiting for materials is a huge waste of resources, and we need to solve this by having visibility. And it's not just visibility of where the materials are, but of the quantities too, to make sure that we have the accurate quantities to make sure we can meet that production runs requirements. So last maths, I promise. This one's not as bad. So an example for a slow running machine. So say we're supposed to be running at 100 meters a minute and we're running at 95. Now it's only 5 meters a minute. It seems, close enough. It's not bad. But so yeah, you've lost 5,000 meters per day though, assuming a 70% utilization. And if you multiply that up over a year, that's 1.8 million meters of production lost by just running at 5 meters per minute slower than you should have been. And the thing to note, that's just one machine. Imagine the losses that's happening if you're just running 5% slower on all machines across the plant. Just look how much waste is going on there. So if you could just increase that from 95 to 96, then you're saving 20% of what we've just listed there. So the conclusion. The thing to know is an MES system for wiring cable is not a utopia. It's an enabler to help you digitize the factory, and it allows us to lift the lid and see what's really going on. But it's not that. It is the tool. It doesn't actually solve your problems. It's the system is not what makes the difference. It's the people using that system. So the system is there to help people, and the buzzword of the past few years is smart factory. But to me, it's not the factory that's smart. It's the people in the factory that are smart, using systems to enable them to make a difference, improve performance, and reduce costs. Okay, so that's the end of my presentation. So I am now going just to hand you back.
And I wanna start by thanking all of our customers, prospects, and leads, and on top of them, the partners that they spend their time to listen to us and to see our updated solutions, how we can support your company in terms of improving the productivity, digitalizing the workshop, as well as organizing and find a new way of working. So my name is Hamada Khalifa. I'm the commercial technical lead of Cimteq by UL Solution, and I will be today, or I will take you in a journey of a couple of our solutions that could change and improve your way of working. Well, I will start the first slide by improvement, and why we started by improvement. If we didn't look if we didn't benchmark our work, will never change. If we didn't look at my neighbor or at my value in the market or at my position in the market, will never come to the change. So improvement, and then finding a new way of working, and last one, by getting those two points, last one, the change will come. Well, the complete cycle of our work in the cable industry. The first one, we start with the data creation. We'll come by one, we'll present what does it mean data creation, and then data release that data to the machine, and then data collection, getting back the feedback of the real production. So you are releasing theoretical data and getting the feedback from of the real production. Then the work environment guideline. How does the operator find the instruction of running the machine, find the instruction of running the cable, find the good way or the best practice of running his work. Then preventive actions and alerts. And last, which Amanda started with, is a human resources. Smart people challenging their current way of work, finding a new way, a new smart way of work that will lead us to build and to start and to move completely to smart factory. And last but not least, is comparing the actual result, actual production versus theoretical production, and build the action plan if needed, and get the value and get the result of what you have produced. Well, come to the data creation. The data creation means engineering, cable, BOM, routing, scrap, the production parameter. Using the CableBuilder, which is our solution and the worldwide leader in building the cable in the right way, in a smart way, in getting each and every details for the BOM. I will come here, building the cable detail design, BOM detail, thicknesses, weight, dimension, getting the drawing for each and every layer and releasing those drawings to the operator in each machine to see which kind of operation that he's running, how the drawing or how the final result of that layer looks like. The routing details, the machine, the task, which kind of machine that I'm going to use, what task I'm going to do, and if this machine is booked, what is the alternative machine, the setup time, the running time, the speed, the overall efficiency, and how to get the result of the overall efficiency for that machine for 24 hours, for 2 days, for 1 day, for 1 week, for 1 month, and the inventory of each machine. And last point in this slide is the scrap details. Look, to control your scrap and to be always in the range of your target scrap, as you are sending to the operator the BOM details, the dimension, the thicknesses, the weight that he used to follow or he has to follow in the operation. Also, from our experience among the market, the cable market worldwide, the scrap details, if you send also the scrap details to the operator, he will have his road map, he will have his square that he has to move inside. Otherwise, you will not have the scrap control. You will use overconsumption, which has been presented by Amanda in the first part. So the scrap details, the length, the quantity, and so on. And last but not least, which kind of drum or bobbin or in-process drum, bobbin or finished good drum that I'm going to use inside the factory. The CableBuilder will give you a recommendation, and if you want to have the real figures of which kind of bobbins, the bobbin size, the drum size, and so on, the CableBuilder will give you that exactly. Then the operator will not struggle, either the forklift operator or the machine operator will not struggle to see which kind of drum I'm going to use. Is the drum fit for my takeoff, for my payoff, and which kind of drum that I'm going to use in the take-up, and so on and so on. So by having the things organized from the first spot, everything, the saving in time will be gradually calculated and collected. And last message from my side here is generating good input to the operator will ensure the good output. Well, how this kind of data will flow from one system to another system? We have two spots here. We have the CableBuilder, which is a robot, giant robot is controlling, the engineering department is controlling, the cable building is controlling, the BOM, routing, drawing, reports, any kind of reports. If you see the number of reports that we could generate with the data that we have generated from the CableBuilder is massive. And converting those reports to have it helpful to the operator, that will be a fantastic tool to guide the operator, to find a new way to the operator, and to have a roadmap to the operator to achieve the target, and even better. So the data will flow from the CableBuilder to the MES. And the MES is another robot who's controlling the shop floor, controlling each and every movement in the shop floor. But what I mean by each and every movement, the raw material, you will see in the coming slides how the raw material is well controlled. The raw material consumption, the raw material management, the thicknesses that I mentioned, the production data, the operation, the BOM data, how the operator will follow his work in order to achieve what you have committed to the client and get it approved. Otherwise, your product is in risk to be rejected by the client, or you will be in risk to generate more, to generate high quality or extra quality, which could lead to extra raw material consumption, which will come in the result of the inventory. In the inventory, after 1 week, or within a week, within a month, within quarterly inventory, you will be surprised if you don't have the things organized, controlled, and managed. You'll be surprised by the raw material variance at the end of each inventory. So we have this three main parts: the CableBuilder, the CableMES, and the machines, PLC, and the system platform. Then the data will flow from the CableBuilder. What I mean by data is what I have presented in the last slide. BOM, routing, each and every details in the BOM and routing in operation, the quality issues, quality parameters that you are measuring accordingly. So this data will move to the CableMES, and the CableMES will control it, or will send it to the machine via the system platform and the PLC. And then the most important is getting the feedback from the machines. So getting the feedback from the machine, getting the feedback from the operator, what he has done during his job to conduct this order. Okay, and then the CableBuilder will be able to compare between theoretical, what you have designed, cost, and get the order accordingly, versus the actual, what you have produced and what you are going to send to the client. And then you will see your progress, if you are the same line, if you are improving, or if you are not improving. One of the most important points that lead us or guide us in the CableMES and the system platform together is a history in place. In history in place, you will be able to record, to store each and every things that you do it in the machine, starting from the day you install the system. What does it mean? What does it mean is, after 1, 2, 3 years, 5 years, 10 years, you will be able to measure your progress in the operation. You will be able to see how much performance that you improve or you disimprove. Okay, and after 10 years or after 5 years, if the operator start to play with the setup or start to play with consumption, then the system will tell him, hey, you have done a best practice here. You are not allowed, otherwise there is a reason to use more material, or there is a reason to use more time in the machine. And the reason has to be justified well from the operator and approved from his boss. And in this way, you will be able to measure how much the consumption they're using, how you'll be able to control the raw material consumption, as well as the machine time. And again, I'm just repeating what I've said before. Those small times and the raw material, getting the raw material ready, getting the drums ready, getting applying the right speed for the material, all those, getting the quality inspector or getting the operator measuring what he's doing, all those times when you accumulate it, you will see the huge time that you were not noticing before, and you will see the improvement of your line. Last but not least, production, quality, and manufacturing instruction will move from the CableBuilder, which is generated automatically, was part of it was the feedback from the real production, to the MES, and the MES will control all those parameters. Well, the CableMES will not be linked only to the CableBuilder. The CableMES will be linked to the testing devices. What does it mean? You will eliminate, or you will reduce as maximum as you can the human interfere by measuring the things, then writing in a paper, getting this paper to key in another system. So the CableMES is giving the chance to have the integration or to have the link with the devices. Whenever you test, it's gonna report straight away to the CableMES. Then you save in time, and the most important, you save in accuracy. Sometimes you can measure the resistance, and the guy, when he enter in the paper, he might put a wrong figure. I'm not telling you it's always, but sometimes putting a wrong figure mainly in the resistance, in the conductor resistance, it costs a lot of money. So those are a couple of devices which is strictly focusing in the thicknesses, as well as in the lay length, in the lay direction, as well as resistance. And overall, taking or capturing all the information related to the machine and putting straight away or feeding it straight away to the CableMES and then CableBuilder or the ERP, or both together. On-time action. The CableMES, what always we are saying is the CableMES is preventive action. What does it mean? Preventive action. The system will control the operator not to send the bad product to next process. So as you can see here from the screen, the system allow the first two reels to pass because they are within a range, but the last reel or the third reel was getting a failure. The failure may be from the extrusion, maybe from bad setup or wrong setup, or maybe from something else, maybe from the tension of the machine, and so maybe from the viscosity of the material itself, maybe from the wrong water path temperature. So all this kind of parameters, if you want to prevent it to have the third reel, you can have all those setups setting it correctly in the cable builder. Then the instruction will go to the operator, and the operator will take more care to set up the right parameters from beginning in a right way. And then the system, for the bad product, he stopped, hold it, and send it to the hold zone. So the corrective action on time is blocking and preventing the company to produce a wrong product or to continue in the next processes where you will face at the end of or at the finish good test that you have produced something wrong at the drawing or at the stranding or at the insulation. Well, one of the strongest parameter in the CableMES is bobbin and drum traceability. And this one, frankly speaking, this one is one of the pain that most of the cable factories are facing it. The operator doesn't know, or he has limited information about when he's going to receive his bobbins, his in-process bobbin or his in-process drum. Or even in the final test, the testing lab, he doesn't know when he's going to receive the finished good product to test it and to release it to the client. What does it mean? It means that your operator, he will never be ready for the drum until it is there. But with CableMES is different. In CableMES, he might have a notification few minutes before, half hour, in the setup that you would like, and the guy and the operator will be ready to receive the bobbin, ready with the tool, ready with the raw material, and all this kind of things. And what does it mean? It's a saving in time. And what does it mean? It is a cost and money. And what does it mean? Your cable will be on time to your client. And what does it mean? You will be prevented of paying a penalty to the client in case of delay. In the coming photos, you will see some of the bobbins that controlled by the CableMES. Here are bobbins used for the drawing, then in-process bobbins, as well as the finished good product. So all stages or each stage are controlled well from the CableMES. Quality versus performance and availability. So once you have the quality data, sending on time to the machine, then you will have the good performance of that machine. And once you have the good performance of that machine, then you will not lose much time on the machine, and you will build your availability. And as I said in the past, all the small time at the end, it is accumulated, and you will have a big figure that presented even more than 25%. It depends on the factory size, it depends on the number of processes and number of machines. One of the strongest points that we have it in the CableMES is a report. As a plant manager, as a CFO, as a CEO, as a production manager, you want to see which machine are performing well. What is the OE of those machines? and with this kind of data, you will be able to feed the sales team, and the sales team will be able to give the right forecast to the plant, as well as to give the delivery time correctly to the client. Otherwise, you will not be able to know those kind of things. And what is good in the reports, you will get the accurate information. The report is calculating and considering each and every movement, each and every steps, each and every stops of the machine. In the coming pictures, you will see some of the reports that could be generated by the system. And if you have any recommendation from your side, please feel free to text in the chat box, and we'll consider that. The first report is plant overview dashboard. And in the plant overview dashboard, will give you a general overview about what is the overall efficiency of the plant, what is the availability of the plant, what is the availability per zone, and per machine. And for those percentage that is not available, you will have the reason why it's not available. It's due to maintenance, it's due to no orders, or due to less resources. And all this kind of things, like what Amanda presented at the beginning, smart people reporting these things on time, you will have the smart system. So without smart people, the system won't work. Like you have a Ferrari, but you don't know how to drive it. So you have a fantastic car, you don't know how to drive it. The next report is the downtime of the plant, downtime of the machine, and accordingly you will see the availability of the machine and more details about the manufacturing quality dashboard, the total operation or total production, the bad product, the good product, and the average production rate, and so on and so on. Those are our famous product, most of the reports that needed by our clients. But again, if you have any recommendation or any special requirement that you want to see, if the data generated, definitely you will have the report, and we can design the report according to your format. One of the most important point for any cable factory, in fact, for any factory, that the raw material management, how I manage my raw material. Well, in the CableMES, you have a fantastic control for the raw material, starting by the most expensive part in the material, which is copper. And for the one who has a special cable, they have a special parameters, but the copper is the most important and most expensive part in the cable, at least for the power cable, and so on and so on. Polymer, steel, as well as the copper tape. If we take it from the first step, for the raw material reception, the system will support you to welcome the new raw material, and then to enter the raw material in the system by scanning or by issuing the barcode. Then the visual inspection will be led by quality or the operator or whatever who is, and the system will control this point by the things passed will go straight away to the shop floor, and the things not passed, you will issue the non-conformity and you will communicate it to your client. So once the material sent to the shop, to the warehouse, when the material sent to the warehouse, the material is laid there and waiting for the order to be released and go to the shop floor, and the system will control that accurately. It has been presented very well by Amanda, thanks to her effort. Well, I will end my presentation by a couple of points about Cimteq and about our acquisition with UL. Cimteq, as most of you knows, that we have been founded in 1998, focusing in the cable industry. We are not software company, we are software skilled by cable experts like Amanda, and we have 3 cable experts here in the company. And then we have 3 main products the CableBuilder Enterprise and the CableBuilder Go, which is a light version, which could help you fast to serve who they have limited budget or a limited production area. And the last one, which is a big muscles guy called CableMES. Our aim is to provide industry-specific software solution as well as cable operation support to the wire and cable manufacturing industry. And last one, as everyone knows, that we have been acquired by UL Solution three months ago. From the worldwide map, if you see, before the acquisition, we were existing in 255 plants, 45 countries. With UL, we became bigger and bigger, and we are waiting to support you from Cimteq by UL Solution and our mother company, UL Solution. So Amanda, you want to take the first one, or I have no issue?
So I'm seeing one. How does CableMES attend to or stop a malfunctioning machine affecting the quality of a product? So that's a good one. So I can answer that if you want, and please feel free to comment if I miss anything. So the first thing is if in terms of the quality management system for the product, when a bad quality product is produced, we should immediately detect it, because whatever the quality plan is for that product, we should know what defines a bad product. So say it's out of diameter, the diameter gauge will flag that. MES will then flag that we're making bad product. So if it's something to do with the machine that causes this, so I don't know, maybe a temperature is not right, maybe one of the temperature controllers has gone down on an extrusion line, then again, if that eventually leads to bad product, we will detect it through the measurement systems on the line. However, we can take that a step further if you want. So basically, it may take a while for the machine to malfunction, and it's going to cause bad product, but not for a while. However, if we through an MES system, we could still be monitoring the temperature zones and so forth. And when something happens on the machine, that means the machine is not performing correctly, then we can also monitor log that and create an alarm to create the warning, which potentially can then avoid having bad product at all, because we get the early warning from the machine. So as long as we have the controls and facilities on the machine to measure when a machine is malfunctioning, then potentially that will allow us to avoid bad product being produced in the first place. I hope that answers the question.
Thank you so much, Amanda. Again, for the one who asked, please
go ahead. Just to add as well, so what we're saying here is that we're flagging it so that the operator or somebody can do something about it, but there's nothing to stop you taking that a step further. And the system, once it detects a bad temperature or something malfunctioning with the product, with the machine, there's nothing to stop us ramping the line down automatically. So there's potentially no human involvement, but I'm not sure that might be taking it a step too far. I think best to check, best to let the human check.
Thank you so much, Amanda. So please, for the people, when we answer the question, if there is something missing, please text us again to the email, and we'll make sure that you get the right answer or the complete answer. So in the Q&A, we'll try to not make it so long, and we can have one-to-one meeting to explain more and to express more about your need and what you're looking for. I found an email from, I found a message from a question. What is CableMES? The CableMES is, in short, is a cable manufacturing execution system that control everything, every movement in the shop floor. So it's taking the information from both ERP as well as CableBuilder and applying those information in the machine. So controlling the product, controlling semi-finished product, raw material, scrap, and so on. So I hope that shortly we're gonna also send you the brochure to read more about the CableMES. And if you have any question, I will be more than happy to support you. Amanda, can you take the second one?
Okay, the next one that I'm reading is what equipment do we need to measure OEE, i.e. the hardware requirement to feed into the software? Right, So to be honest, the bare minimum you need is a length measurement and a speed, because from those two, we can automatically determine the performance and that therefore the availability. The quality, it really, if necessary, the quality can be entered manually by the operator. So that would determine whether the quality is good or not, and that would give us the OEE. But further, if you want to do the quality automatically, then you would need the whatever values we're measuring for quality, whether it be, you know, diameters, lay lengths, whatever, you would need equipment on the line to measure it. But if you haven't, it's not really a problem, because we're going to potentially ask the operator to take the measurement and enter it. So the bare minimum, if you have a length count and a speed, then you can get the majority of what you need for OE for every machine.
Very good. I have a question from one of our clients. Can we use the CableMES with CableBuilder Lite version, which is CableBuilder Go? The answer is, as you know, the CableBuilder Go is not yet linked to the MES and to the ERP, but we will discuss this one separately. What could be done in order to link the CableBuilder Go with with the ERP and CableMES? Well, the second one, please, or the next one, Amanda.
Okay, I'm just going back up a bit. This one, I'm not quite, I'm going to read it out. I'm not sure if I quite understand
no
it.
problem, just pick anyone.
Let's just read it out. Shortage of materials result is acceptance of material, which may not be 100% correct, but production and shipment schedules force us to use such materials. How this situation is being looked at by CableMES. I think this, I'm guessing this is sort of referring to using alternative materials. So you've been given a material in your bill of a spec in your bill of material that says to use a particular material, and that material is not available, but there's an alternative. Then how do we manage that? And in MES, in CableMES, there is a way to deal with the alternative materials. So if something, effectively, you can override the bill of material. So somebody has to approve it, because you can't just pick up anything. Somebody has to approve it, say, okay, we can replace that material with this one, and production can continue. So yeah, we can deal with that situation, which does, I know it does commonly occur. Okay. I'm just going higher up now, because there's some more higher up.
How does the CableBuilder attempt to stop the machine affecting the quality or product? Did you answer this one?
No, can't see that one. Is that?
Well,
you want to answer that one?
Yeah, you want to answer?
You go for it.
Okay, so for the CableMES, as you see at the third slide of my presentation, there is an alert that you could set up to give the control to the system, like a robot, to give the control to the system to stop the operator or to stop the machine against any deviation to the standard. So first of all, the information will come from the CableBuilder or the ERP or both together, including each and every parameter, like the thicknesses, like the things that the client will concentrate during the FAT. Okay, that the things that you are afraid that your product will be refused by the inspector. So those parameters will be set in the CableMES, and we will give the control to the MES. If you see something different to the input, please stop the machine, or give an alert, or give an alarm to the operator N+1, N+2, N+3. For some of the machines, stopping the machine is so difficult, then you will have some execution, or you will have some something to mention that, okay, I will not stop the machine, but I will correct online, like civil line, like the things that if you stop the machine, it's gonna cost a lot. And then once you pass the bad product, then you can cut and continue your product. I hope that I answer your question, but some of the machines you can reach the alerts to the CEO, to the chairman. Okay, and some of the alerts that could pass or could go to the supervisor and so on. Well, next one, please, Amanda.
Okay, there's one. My machines are old. Can I still use CableMES? So the answer to that one really, in any factory, realistically, there's going to be a mixture of maybe some more modern machines and some very, very old machines. And so the thing about an MES system is the thing that when you install it, you need to capture it across the whole factory, because you can't have it running in islands. You don't really achieve what we're trying to achieve. So even though the machine may be old, as a bit like the OE, the minimum, if we can collect the length and the speed, that gives us a massive amount of information to work with to basically include that machine in the whole MES system. And where some things can't be automated, as they could be on other machines, then we have to infill that with some manual entry. But it doesn't really affect the view of the whole system. Maybe you're not getting as much information from that machine as other machines, but when you look at the whole picture, you're looking at the whole factory with every machine included, whether it be old or new. So yes, you have to use MES with old machines. There's no other option. We have to find a way to do it.
And just to add to you, Amanda, all of the machines will be inspected by our expert during the scoping workshop. So once we start, the first point that the first step that we start with, especially for the CableMES and the CableBuilder, is a scoping workshop. 1 or 2 people from our side will come there to inspect all the machines, to see the physical situation of the machine, and based on that, we'll give the proposal. I do agree with Amanda that all of the machines will be connected to MES, whatever there is a PLC or alternative solution, but we will make sure that we get the maximum information of those machines. Well, can you integrate multiple plants, manufacturing or central? Yeah, we have done this one. With Nixon's. So I think yes. The answer is yes. We can integrate multiple plants or centralizing the software. Well, the next one, Amanda, please.
Can reports be customized as per user-specific requirements? Most definitely yes, because I've never known any report that you try to give to one customer and give the same report to the other customer. It's never right. So yeah, basically, the answer is most definitely yes. That and ideally, we train you to do it as well, so you don't necessarily need us to do it.
Yeah. We teach you how to create your reports, so you can do it in a way that you like, in a fancy way or in a standard way. The CableMES will have a standard report, but you are the owner of the system. You are the owner of the report, like the CableBuilder. We don't give the format for one client to other client. None of our clients has accessibility to another database. So you are the owner of the system. You can design your system and your reports in your way. Next one, can you recommend length counter and speed measurement devices that would work with the CableMES? I think all of the meter lengths and the speed measurement devices will work with the CableMES. There is no point for it.
It should do. I mean, normally it would come through a PLC to Underwear, but as long as the equipment has a driver that we can talk to it through, then there shouldn't be an issue. But if you've got anything specific that you'd like to check whether we could talk to it, then just contact us afterwards and we can double check that whether that would be an issue or not. But I've not known anything so far that we can't talk to. If it doesn't, it's not obvious to start with, we generally always find a way.
Thanks, Samantha. The second one, or the coming one, is, can your solution can be integrated with the ERP? Definitely yes. There are 2 inputs for the CableMES. The CableMES is like a machine, so it should have input in order to give you the output. So the input coming from both the CableBuilder as well as the ERP. So the answer is yes, definitely will be integrated with the ERP and the CableBuilder. Please, Amanda, can you take the next one? Does CableMES have
CableMES a function to support finished product inventory for manufacturing and supply operations? It does, but no, normally the MES system is about the manufacture. So once the finished goods are complete, they will be in MES, but we would normally effectively park them there or send them to the ERP or the whatever system manages in inventory. But we do have a warehouse management system within MES, but typically people have something else that manages that. So we typically send the information of the finished products, and then we're finished. But it could do it if you want it to do it.
Thanks, Amanda. The next one is your solution is cloud-based? I think you mean cloud-based or physical server required? Yeah, it's a physical server required. So you will need a physical server for the CableMES as well as the CableBuilder.
So yeah, I mean the actual technology. There's no reason why it can't be cloud-based. But the issue really is with the nature of the communications that we're doing with the machine, which are in real time, have to be quite fast. So we rely on that network being solid and there and fast. So there's no reason you couldn't put it in the cloud, but you need to be sure that that connectivity to the cloud is always there and reliable and high speed. So sometimes people normally choose at the moment to put things as a physical server in the plant. But I think the way things are going in the future, that may change. But our technology wouldn't need to change. The server can be anywhere. It's just at the moment, it's probably better in the plant because it's more reliable and for the fast communications to the machines.
Yeah, for connectivity, most of the some of the countries, they don't have strong internet, or they might expect interruption in the internet, and interruption in the internet, like interruption in the power, could impact your production. Does the CableBuilder have a costing feature as well? Yes, why not? Because once you produce, you have the raw material, you have the production cost, then we can build the costing feature. One of the most important feature for our systems, both CableBuilder and CableMES, is flexible. So once you have a special requirement, the system is really flexible to be adopted and to have your special requirement included in the system. Amanda, if you want to say something at this point.
Yeah, I think so. I mean, the CableBuilder for sure has costing, so that you actually this is the specification of what you expect the cost to be. On the CableMES side, really everything is there. It would be some sort of report. So depending on what you want to cost, it would be a report that would pull from the data that CableMES has collected. It can also compare it to whatever is in CableBuilder for what you expected the cost to be. So I wouldn't say it's a costing feature, but everything is there is to build whatever sort of costing report you would like to come out of the system based on the data we've collected.
Absolutely. I think that's all of what we got at the moment. Again, I encourage you to send us more questions. We'll be more than happy to support you. And I give the lead to Ken. Thank you so much.
Thank you very much, guys. So thank you to Amanda and Hamada for answering all those questions, and thanks very much to everybody who sent in a question. As Hamada mentioned, more than happy to take any questions after the webinar and follow up on a one-to-one basis. So lastly, thank you once again for joining with us today, and we hope to see you at future webinars and events. Thank you very much.